Okay then, so now hopefully you're beginning to understand the basics of how generic functions work in TypeScript. But it's not only functions that can be generic. You can also make generic type aliases, generic interfaces, and generic classes. So in this lesson, we're going to take a quick look at generic interfaces. So these work much in the same way as generic functions, in that we can capture a type that we pass into the interface at the point in which we use it essentially. And then we can use that captured type to assign types to different parts of the interface. So let's do a quick example. I'm going to make a new interface called collection, which is going to describe an object that has two properties. The first property is going to be a data property, which will be a string array. The second property is going to be a name property, which will be a string. So you can imagine we might have a collection for a shopping list, and the data property would be an array of all the items in the list in string format, and the name value might be something like shopping list. Or we could have a collection of actors from Star Wars films. So the data would be an array of all of their names as strings again, and the name would be something like Star Wars actors. So this interface would work really well for any collection where the value in the array of data would be strings. But what if we had a collection that wasn't strings, for example, a collection of dates, or a collection of numbers, or some kind of custom object like user objects? Well, this interface in its current form wouldn't support those because we say the data must be an array of strings, but we could make this a generic interface by adding the angle brackets after the interface name, then adding T. And again, this doesn't have to be called T, it can be called anything you want. But more often than not, you'll see this being called T. Anyway, now we're saying that when we make an object based on this interface, we're going to declare this type T when we make it. Then we can use that type to define what type of data should be in the array down here. So I could say T instead of string, and that would mean the data would be an array of items which all have this type of T. So then we could make a new collection object using this interface now. And we can do that by saying const collection1 is going to be equal to an object, right? And I'm going to explicitly type this object to be a collection using the collection interface. Now remember, we have to specify now a type for this collection which gets captured within the interface. So in angle brackets, we can say string, for example. And that means this is a string collection, and the type of data inside the array will only be allowed to be strings because T now represents a string type. Alright, so let's flesh this out. So inside here, we need the dates property, which is going to be an array of strings because we said the type here is a string, and it's just going to be names from Mario. So let's do Mario, and then after that we'll do Luigi, and then finally we'll do Peach. Like so. Alright, and then the name of this will just be something like Mario characters. So that is now a collection of type string, but we can also do other types. So I'll say const collection2 is going to be a collection again. This time we're going to pass in a different type. It's going to be number. Like so. Alright, no, we don't need to invoke that. We just set it equal to an object. And then inside here we need the data, which is an array, this time of numbers. So let's do 10, 15, 27, 9, 3, and 34. Alright, so now the name of this one is going to be winning lottery numbers, I wish. Alright, so now we have two collections here, don't we? We've got this collection, which is of type string for the data, and this collection, which is of type number. We can also use this generic interface as an argument type in a generic function. So for example, we might make a new function called something like random collection item, which accepts a type because it's going to be generic. So we can open angle bracket to do that and say T to accept that type. And now anytime we call this function, we can specify what type we're going to pass in, right? Now in parentheses, we can say we want a single argument called C, which will be of type collection. Now remember, when we type something as collection, we have to now specify the type because it's a generic collection. So after collection, we can say angle brackets and then whatever type of collection this is going to be. Now, if we had code something like string or number, then this function is no longer really generic because we're then limiting the type of collection that we can use with it. So instead, we can pass t into the angle brackets. And remember, t is the type that we pass into the function as well. So when we invoke this function, if we pass in string as the type, then the argument will be a string collection. Does that make sense? If we pass a number as type, then the argument will be a number collection and so forth. Now, as a return type, we're going to say t because we'll be returning a single random item from the collection data, and the data is an array of items of type t. Alright, so now let's flesh this function out and try using it. So what I'm going to do inside the function is say, first of all, const I is equal to math.floor, and then inside parentheses, math.random, and invoke that, and then we're going to times c.data, oops, not debugger. We want c, and then dot data, and then the length property of that. So that's the length of the data array. We're timesing that by a random number, then floor in it, so that gets us a random index between 0 and the length of the collection, basically. And now we can use that to return a random element from the data. So I can say return c.data, and then pass in I to get that random element. And this is going to be of type t, because we know everything in the array is of type t, right? So let's come down here and try using it. I'm going to say const result1 is equal to random collection item. And the type is going to be a string right here. And we're going to pass in then collection1. And we know that it's string right here because this collection is a string collection. So let me grab a collection1. Open up our parentheses, pass this in, and there's no errors because collection1 matches the type right here, the string in the string, alright? And if we hover over this, we can see we get a string back, which is what we're expecting. Alright, so now let's try the other one. I'm going to say const result2 is equal to a random collection item. This time, I'm not actually going to manually use this angle brackets thing right here. Instead, I'm just going to invoke it. And I'm going to pass in collection2. Now, this is pretty nifty. TypeScript knows that collection2 has this number type passed into it. And we say right here that t is whatever the type is, this argument. So we're saying that t is a number essentially, so we don't actually need to manually say number right here because it infers it based on this value. Alright? So that's pretty neat. And if we hover over this, it's going to know that we get number back based on this type, which is pretty cool. Alright, so now let's try logging both of these to the console, console.log, result 1 and then result 2, like so. Save it, open up the terminal. And we can see Mario for the first one and 27 for the second one. So that was the random character. And then this one. Okay, cool.